Hi, I'm Jomar Baybay, and this is my video presentation for our final MCO in integral calculus. In this video, I'll be discussing and solving six major topics we've covered throughout the semester, which is the area computation, centroids, volume of solid of revolution, length of curve, area moment of inertia, and finally, work pumping of liquid. For each topic, I'll explain the basic concepts and formula we use. Then, I'll solve one problem step by step, showing how to apply the formula correctly and interpret the result. So, these topics are not only important in calculus, but they're also widely used in engineering, physics, and real-life applications, which makes understanding them extremely valuable. So, without further ado, let's get started with our first topic. So, good day everybody. My name is Jomar Baybay, and today we're tackling our first topic, which is area computation. So, let's start. Before we get started with our problem, we need to discuss what is area in integral calculus. So in integral calculus, we use definite integrals to compute the area under a curve or between two curves. So let's draw a graph, and it has some area, some curve to it. So this is gonna be A, this is gonna be B, and let's say we need to find the area under this curve right here from these 2 points. So let's just name this curve y is equals to f of x. To find the area under this curve, we just need to follow the general formula in finding the area, which is A is equals to the integral from A to B of fx dx. So that's our formula we need to keep in mind. So another thing is, it's just the same for, let's say if we have a curve on this side, that's on this side. So let's name this C and D. So these 2 points in the y axis, and it's just the same. We need to find the area from this side, and let's name this curve as y is equals to g of y. So the formula for it is just A is equals to the integral from C to D. So from C to D, g of y dx. Now, how about when we have two curves? Let's say let's draw another graph. Let's say we have two curves. Then what? And we need to find the area between them. So all you need to do for this, if you have two curves, is just you need to find the difference. You just need to find the difference of those two curves. So to compute this, we just need A is equals to the integral from a to b, so of f of x minus g of x dx. So that's what you need to do. You just need to find the difference of those two curves, and then you can find the area. So let's get started with our first problem. So we have our first problem, which is find the area bounded by the curve. So this is our curve in the x-axis. So, and the vertical lines are x is equals to 0 and x is equals to 3. So first, what we need to do is we need to graph our curve. So let's first draw a graph. Now we know that negative x squared usually looks like this, right? It looks like that. And since it has 3x, we just need to move 3 units in the x direction, so it will look like this. Like that. And our question was we need to find the area in the x-axis, so it will be right here. So we have 0 and 3, so this is 3, and this is our curve right here. Now let's use the formula in finding the area, which is a is equals to the integral from a to b. So this is our a, this is our b, so that means from 0 to 3, and our f of x, which is this right here, 3x minus x squared dx. Now we integrate, so 3, this just becomes, we use the power rule, this becomes 3 over 2 x squared, and again using the power rule, we got 1/3 x raised to 3 raised up from 0 to 3. Then we plug in the numbers, so this becomes 3, 2, and then first we need to substitute 3 minus 1, 3 squared minus, now we need to substitute 2, but if we look at it, it's just gonna equal to 0, so let's just leave it at that. So solving for it, we got the total area, which is 9 over 2 square units. Or 4.5 4.5 units squared. So that's our answer. So now let's move on to topic 2, which is centroids. So before we dive in to our problem, we need to discuss what are centroid in integral calculus. So in calculus, a centroid represents the center of a mass or balance point of a two-dimensional area for a region bounded by a curve and the x-axis. We can use integration to find the coordinates of the centroid. So there, and finding the centroid, we need 2 points, right, from the x-axis and the y-axis. So there's gonna be two formulas that we need to memorize. So in finding the point in the x-axis, we need to, the formula is x bar is equals to 1 over a means area, times, the integral from a to b, x times f of x dx. So that's our formula for finding the x point. Next is the y. So to find this, it's just 1 over a, the integral from a to b. So instead of x, we use, it is 1/2, and our function, and then there's gonna be a squared enter. So don't forget the square. So this is both of the formulas that we need to use. We just need to find the area, and then the area first, and then we can now solve for the centroid. So on to our problem. So we'll find the centroid of the same region from our topic 1, which was finding the area under the curve, which is y is equals to 3x minus x squared between x is equals to 0 and x is equals to 3. So in our last topic, we discussed all about areas and how to find them, and we know that the area for this problem was 9 over 2, right? Now that we have the area, we can now proceed in finding the centroid. So let's start first in finding the x bar, which is 1 over a, the integral from a to b, x times the function of x dx. So plugging the numbers in, we have 1 over our area, which is 9 over 2, from a to b, which is 0, from 0 to 3, x, and our function, which is 3x minus x squared dx. So first, what we need to do is we'll expand the inside of the integral, and this we can just simplify this into 2 over 9, right? 0, 3. So x times 3x, that's gonna be 3x squared, and x times negative x squared, that's gonna be negative x cubed. And now let's just write it here. Now let's integrate.
So 3x, we will use the power rule. So this is gonna be 3x cube over 3, and the 3's will cancel, so it's just gonna be x cube minus x4 over 4. We can just write it as 1/4. 1/4. Let me rewrite that. 1/4 x raised to 4 from 0 to 3. Now we can plug in the numbers. So this is just gonna be 3 raised to 3, 1/4, 3 raised to 4 minus from 0, and if you look at it, 0 raised to 3 is just 0, 1/4 times 0 is just gonna be 0, so let's just put it 0. And solving for this, we get 27 over 4. And now if we multiply 2 over 9 times 27 over 4, we get the answer, or x bar, we get the answer of 3 over 2, or in decimal we get 1.5. So that is our x bar. So now that we have our x bar, which is 1.5, now we need to solve for the y bar. So again, our formula for that is 1 over a, the integral from a to b, 1/2 times our function, and don't forget the squared. So, yeah. So let's write our values in. 1 over a, our area is 9 over 2 from 0 to 3, 1/2, and our function is again 3x minus x squared. Then there's gonna be a square there, and then dx. We can simplify this, just bring the 2 on top, so that becomes 2 over 9. And since 1/2 is a constant, we can just put it outside of the integration, so that's just gonna be times 1/2 from 0 to 3. And this, we just need to expand the square. So basically 3x times 3x, it's just gonna be 9x squared, and then 3x times negative x squared is gonna be negative 6x cube times negative 6x cube, 3x cube, I mean, it's gonna then, so 3x cube minus 3x cube, it's just gonna be negative 6x cube. And then negative x squared times negative x squared, that's gonna be positive x raised to 4. So now that we expand our square, we can now integrate. So 2 over 9 times 1/2, that's just gonna be 1 over 9. Oops. 1 over 9. So 9x cube, we're gonna use the power rule. That just becomes 9 x3 over 3, but we can simplify it by just dividing it to 3, making it 3x cube. Again, here we have 6, it's just, we're gonna use the power rule again, it's just gonna be 6x 4 over 4, and simplifying it, it will just become 3 over 2 x raised to 4. And for this, it's just gonna be 1 over 5 x raised to 5 from 0 to 3. Now, we need to plug in the numbers. So, this is just gonna be 3 raised to 3 minus 3 over 2, 3 raised to 4 plus 1, 1/5, 3 raised to 5. And if we look at it, minus, so we can just put 0 because everything will just equal to 0. So this just is just, if we solve this, it's gonna give us 81 over 10. And 1 over 9 times 81 over 10, it's just gonna be 9 over 10, or 0.9. So that's our y bar, and this is our x bar. So the centroid is gonna be 1.5 and 0.9. So that's our final answer. So moving on into our third topic, we're gonna tackle all about volume. So in this topic, we'll calculate the volume of a solid of revolution using definite integration. So when a region is revolved around an axis, it creates a 3D solid. So we either use the disk method or the washer method to find its volume. So let's say we have a graph and we have some curve from A to B, and this is the radius, call it R. So if we revolve it around the x-axis, it creates sort of a disc, a 3D shape like that. So if we draw it here, it looks like a cylinder, right? So we have the radius, and the volume of this, right, of a cylinder is pi r squared times h. So because this is our height, right? This is our height. So if we look at this, we can see that this is gonna be our height, or h, where we can just call it dx, right? And this part is gonna be our volume, which is pi r squared. So the concept of it is that we need to find the total, the volume of this solid. So we need to use integration because we need to find all of this disk, because it has smaller disk. So we have a smaller disk right here, from right here, right here. So we need to calculate all of that. That's why we're gonna use integration to find it. So to find the volume using the disk method, it's gonna be V is equals to pi So from the integral of a to b, r of x, which is just gonna be our function, so let's just call it f of x dx, and this is gonna be, and I forgot this, it's gonna have a square on it because the volume of a disk of a cylinder is pi r squared. So this is our formula that we're going to use. Let's proceed to our problem. So here's our problem. Find the volume of the solid formed by rotating the region bounded by the curve y is equals to square root of x, and the x-axis from x is equals to 0 and to x is equals to 4. So our function, this is our function. We need to graph it first. So we know that x squared y is equals to x squared. It's gonna look like this, like that, and the radius is the distance between the curve to the x-axis, to the axis of rotation, which is gonna be in the x-axis right here. So that is gonna be our radius. So this is gonna be our volume that we need to find. So if we recall our formula on finding the volume, which is v is equals to pi, the integral from the integration of a to b, f of x squared dx. So this is gonna be 0 to 4, from 0 to 4, and our function is gonna be, our f of x is gonna be square root of x. We can just write it off as x squared raised to 2 dx. Now we just need to integrate. So this is gonna be x raised to this is just gonna cancel, I mean, because we have square root of x, right? I'm sorry, we have square root of x raised to a squared. It's just gonna cancel, so we're left with x, and if we integrate it, we use the power rule. So we have 1/2 x raised to 2 from 0 to 4. So we have pi, substituting the values, so we have 1/2 4 squared minus, again, if we look at it, if we replace this as 0, it's just gonna equate to 0. So 4 times 4 is gonna be 16, and 16 times 1/2, that's gonna be 8. So therefore our final answer, so our volume is just gonna be 8 pi cubic units. So that's our final answer. So moving on to our next topic, we have finding length of a curve. So let's say we have a curve from point A and point B, and we want to calculate the length of this curve right here. So how do we do that? We'll use the formula for finding the length, which is the arc length from A to B square root 1 plus f prime of x squared dx. So this is the formula that we need to keep in mind in order to find the length of a curve. So let's try some problem. So here's our problem. We have f of x is equals to 1 plus 6x raised to 3 half, where we have from 0 to 1. So our formula was the arc length from A to B square root 1 plus f of x squared f prime of x squared dx. Now because we're looking for f prime of x, which is the derivative of this, we need to derive this function. So we have here f of x is equals to 1 plus 6x raised to 3 over 2 f prime. So the derivative of this, 1 is a constant, so it's just 0, and 6x raised to 3 halves, we need to multiply, right? We need to bring this down, so it will be 6 times 3 over 2 x raised to 3 over 2 minus 1. So if we're gonna solve it, it would just be 6 times 3 over 2, that would be 9, and 3 over 2 minus 1 will just be 1 half, or we could just say square root. So now that we have our derivative, our f prime, we can now insert it into our formula. So this will be, our a would be 0 to 1 square root 1 plus our f prime would be 9 squared x squared dx. Now we have to just square this. This will cancel, right? The square root and the squared, you can cancel those. And 9 times 9 is just 81. So it would be 81 x dx. Now we need to integrate. So let's make u 1 plus 81x, and the derivative of that is just gonna be 81 dx. Solving for dx, we get du over 81, right? Now we need to solve for these two right here from our a and b. We need to change it. So what we want to do is we want to plug in these two numbers using this equation. So I'm gonna plug in 0, so it will be 1 plus 81 0. So this will cancel, it will just give us 1. And what if I plug in 1 into this equation? It would be 1 plus 81 times 1. That would give us 82. So I'll write it here. Our new equation is gonna be, instead from 0 to 1, it would be from 1 to 82, and then we can just write it as u, square root of u, and our dx will just be du over 81. So we can just write 1 over 81. So it will cancel. So 82, 1 over 1 to 82. And then square root of u du. So now that we have this, we just need to integrate 1 over 81. Square root of u, we can just write it as u 2 over 3, I mean 1/2, and using the power rule, we add 1, so that would make it 3 over 2 over 3 over 2, from 1 to 82. We can move this to the numerator, so that would be, and since it's a constant, we can just move it outside. So let's just do like this, 2 over 3, and then we will have u raised to 3 over 2. Now we plug in the numbers. I'll just write it here, 81. So let's just solve it. 1 over 8, 1 over 81 times 2 over 3, that would give us 2 over 243. And now if we plug in 82, if we plug in 82 to this equation, so we have 82 raised to 3 over 2 minus 1 raised to 3 over 2, that would give us 2 over 243. If we solve this, this would give us 741.54. And now if we multiply 2 over 243 times 741.54, we get 66.103. So that's our length of our curve right there, approximately 6.103. So next topic is area moment of inertia. So now we're solving for the moment of inertia about the x-axis. This concept is important in engineering because it tells us how resistant a shape is to bending. So take a ruler for example. So if I lay it flat, just flat right here, like this and I bend it, you see how it has basically almost has no resistance to it, so it's bendable, right? It's prone to bending. But if I turn it like this way, right here, and I try to bend it, it has a lot of resistance. So for solving the area moment of inertia, it's gonna tell us how resistant a shape is to bending. So before that, the formula in finding the moment of inertia about the x-axis is basically Ix is equals to the integral from a to b of f of x squared dx. So that's what we should memorize. So let's proceed to our problem. So we're given y is equals to x squared from x is equals to 0 to x is equals to 2, and about the x-axis. So let's first draw a graph. X squared looks something like this, right? So from 0 to 2, so we need to draw a horizontal strip right here. So this is our function. Basically, we just need to use our formula to solve this. So this is x right minus x left, and then if we try to solve it using our formula, which is I of x is equals to, from the integral of a to b of f of x squared dx, and now we have our values. We just need to plug it in. So it's gonna be 0 to 2. From 0 to 2, our function is x squared. So x squared dx. So what we need to do first is multiply x squared times raised to 2. Raised to 2. It's just raised to 4 dx. Next we integrate. So it's gonna be, using the power rule, it's gonna be 1 over 5 x raised to 5 from 0 to 2. Now we substitute the values in. So it's gonna be 1 over 5, 2 raised to 5, minus, and if you look at it, it's just gonna be 0. So if we solve this, this is just gonna be 32. 2 raised to 5 is gonna be 32 over 5. Or if we put it in decimal, we get 6.4 units raised to 4. So that's our final answer. So on to our last topic in this video. We have work pumping of liquid. So in this topic, we solve our real world application, work in pumping liquid. So work is the force needed to move a mass over a distance. Basically, when pumping a liquid out of a tank, we slice the tank, pumping liquid out of the tank, we slice the tank into thin horizontal layers, and add up the work for each slice using integration. That's why we will use integration for this, because we are slicing the tank into into horizontal slices and basically adding up each slice using integration. So the general formula we're going to use is for work is equals to the integration from a to b of rho, this is not power, this is rho, basically density, times gravity times area of y, and distance of y dy. So this is our formula that we're going to use. Let's move on to our problem. So this is our problem. A tank in the shape of a cylinder with the radius of 2 meters and the height of 4 meters is full of water. How much work is required to pump all the water to the top of the tank? So let's draw a figure. So let's say this is our tank, and it has a radius of 2 meters and the height of it is 4 meters. So the question is, how much work is required to pump all the water to the top of the tank? So we know the density, which is rho, of a water is 1000 kilograms, kg over m raised to 3, and we know gravity is equals to 9.81 ms squared. So using our formula earlier of work is equals to the integral from a to b of density times gravity times the area and the distance dy. So let's try to look for the area of each slice, basically AY. Now we know that the area of a cylinder is pi r squared, right? And we know our radius right here is 2. So if we plug that in, it would just be pi 4. Now let's find the distance to lift the water of the height to the top of the water. So we know the distance is 4, right? So we're just gonna let's just put minus y from it to find the distance needed to lift the water. So now that we have this too, we can now plug in to our equation. So from our a to b is just gonna be from 0 to 4, and our density is 1000, our gravity is 9.81, our area is gonna be 4 pi, and our distance is gonna be 4 minus y dy. Now, notice all of these three are all constants. So we can just move it outside of the integration. It's gonna be 1000 9.81 4 pi 4 minus y dy. So let's integrate. It's just gonna be, if we solve this, 1000 times 9.81 times 4 pi, it's just gonna be 39,200 pi. Now integrate, it's just gonna be 4y, and using power rule, it's gonna be 1/2 y raised to 2 from 0 to 4. Plugging in, if we plug in 4 into y, we get 4 minus 1/2 4 raised to 2, and if we plug in 0, it's just gonna be, all of it is just gonna be 0, so let's just put 0 in it. 4 times 4 times 4, we got 16 minus 4 times 4 is 16 times 1/2 is just gonna be 8, so 16 minus 8 is just gonna be 8, so I'm just gonna put it right here, 39,200 pi times 8. So our work, if I multiply this, is gonna be 313,600 pi joules, or if we multiply it by pi, we get 985,200 joules. So that's our final answer.